This lesson is about solving quadratics. It does have quite a few slides with it, primarily because we have several examples of each type of solving. So this is truly an informational slide. We have three primary methods that we'll look at for solving quadratics. You can see here in smaller print there is a fourth one, completing the square. If you look at the help me solve this in the Pearson, they will do completing the square, but there's actually an easier way, so that's not the method that I'm going to show. I will focus on the square root method, factoring, and using the zero product property, and the quadratic formula. It's the quadratic formula and completing the square that always work. You really only have to master one of those, so we'll be using the quadratic formula if we can't use one of these first terms. Now when we solve, it may just say solve, but you just as well go ahead and get used to the concept that roots, zeros, and x-intercepts are all essentially the same thing. There is a slight difference in that x-intercepts have to be real numbers, and the others could be complex or imaginary. And when we're finding complex or imaginary roots, we really only deal with the x value, but when we find an x-intercept, then we are trying to find a particular point, and it can be written in the same way. But the x value in this point, x comma 0, is the same value that we would get if we solved or found a root or found a 0. Okay? So what we're going to do in the next several slides is we'll talk about the square root method, do a couple of examples, factoring and zero product property, and some examples, and then the quadratic formula. Some of these examples may be a little bit blurry. I didn't have time to retype each thing here, but since there's no b of x term, so let me just back up for a moment and make sure that you're aware of what I mean by the b of x term. When we have a quadratic in its standard form is generally ax squared plus bx plus c, and then equals 0 whenever we're going to solve that. But here we don't have the term that just got x to the first. So we do have the squared term, and we do have a constant. All right? But these are actually very quick to solve. It's not really any particular thing, although we call it the square root method. What you want to do is isolate the term that has the square. So I'm just going to subtract 12 from both sides here, and that will give me 4x squared equals negative 12. Divide both sides by 4. X squared equals negative 3, and then take the square root, so x equals plus or minus the square root of negative 3. Now when we put that square root on there, we've learned previously that we can take that I out, so I'll put a plus here and an I. That's imaginary then. This one is not real. And so x is equal to plus or minus I root 3. And we have our imaginary root. One more time, but a little bit faster. On this other one, it says x squared plus 16 equals 0. So we get x squared is equal to negative 16. X is equal to plus or minus. Anytime you decide to take a square root, you have to do plus or minus, unless for some reason you know something doesn't apply, like a measurement. We're going to take the I out. And then the square root of 16 is 4. So we have x is equal to plus or minus 4i. Now, of course, they wouldn't have to have an I in them, but we need to go ahead and kind of review that as we go along. Now, factoring in the zero product property. The last couple of slides at the end, I do help with factoring. So here I'm going to go through this fairly quickly so that you might just be refreshed on it, or maybe you already know how to do it. But if you need help with factoring, you need to stay tuned for the end of this video. So first of all, these first two are already factored. If we're going to use the zero product property, the zero product property actually means that if A times B equals 0, then either A is equal to 0 or B is equal to 0. So if you have two things multiplied to give you 0, one of your things has to be 0. And that's what applies here, because we have a first set of parentheses times a second set equals 0, which means either the first set is equal to 0 or the second set is equal to 0. Now, for the sake of room, I'm going to go ahead to the results of this. If I take 3 over to both sides, I'll get 2x equals negative 3. Divide both sides by 2, and I get negative 3 over 2. On this one, when I bring that 2 over, it'll become positive, so then I'll get positive 2 over 3. So for a little bit nicer writing, we'll put it over here underneath the 0. That means I have negative 3 over 2 and positive 2 over 3. Now this is not a point. This is a set of two possible answers here that would both work. It always turns out that when you are doing this, it takes the second term and changes the sign when you bring it across the equals, and then you divide by whatever was in front of x. So I can essentially, by inspection, which means just by looking at it, know that the solution to this one will be positive 2 over 5. And the solution for this one will be negative 3 over 2. You can just write it out equal to 0 and solve each little step if you need to. But now these next four are not factored. They are grouped. These first two, you don't see a number in front of x squared. It's just got the 1 there, so it's actually easier to factor. You can essentially just kind of bounce back and say what multiplies to 20 but subtracts to negative 8. And if I put x minus 10 and x plus 2, that's factored. So then looking at each one of those factors, I can write down my solution set, and I have 10 and negative 2, because those are the numbers that would make each parentheses equal 0. Again, because there's no number in front, I can just kind of bounce back. What multiplies to 8 but adds to 6? Well, that's going to be 2 and 4, so I have x plus 2 and x plus 4. All right, so my solutions then are negative 2 and negative 4, the numbers that make that equal 0. Now, when you have a number in front, that just requires a little bit more. So at the beginning, you want to ask yourself, is there anything that divides out of everything? And there's not, so there's no common factor here. I'm going to do kind of scratch work off to the side here. What I do is I think through, okay, first of all, take A times C. So 3 times negative 2 is negative 6. And then what multiplies to negative 6 but subtracts to give me that middle term of 1. And that's going to be a 3 and a 2. Put them both over the first number, 3. Reduce, so this one just reduces to 1, which is how I know this one will be x plus 1. And the other one will be 3x minus 2, because the bottom number swings up to the front. Now again, there are other methods you may have learned to factor. If you don't like this method, I'm not at all concerned that you use this exact the way I'm saying it, as long as you can factor this. This gives me my solutions of negative 1 and positive 2/3. Now on this next one, the very first thing I would see is that all of these numbers are divisible by 2. So if I divide everything by 2, I get 5x squared minus 8x plus 3 equals 0. And somebody might ask, well, why didn't you just factor it to the front, kind of like undistribute it? But since there was an equals, I was able to do it on both sides of the equal sign. If there hadn't been an equals and I'd only had the 10x squared minus 16x plus 6, I would have factored it to the front. But now, looking again at kind of this process of 5 times 3, you want to take the a times c, is 15. What multiplies to 15 but adds to give you negative 8, that middle term? Well, negative 3 times negative 5 is what's going to give me negative 8. I need to put them both over my first number and reduce, which makes that second one there negative 1. So now my parentheses, bottom number comes up to the front. I have 5x minus 3. That I'm getting from this negative 3 over 5. And then the next one is just a minus 1, so there's nothing that I need to swing up to the front, so it's x minus 1. And so now my solutions are 3/5 and 1. So again, if you need more help with factoring, we'll have some more slides there at the end to help out with that. Okay, now if we're looking at a graph, it is actually much easier provided that you can tell where the graph crosses the x-axis. So yay for this, I can see right here and right here. I have 2 places where that graph crosses the x-axis, and that's at -2 and 2. Now, writing it like this is writing solutions. That's different than writing what the x-intercepts are. But again, the x value of the x-intercepts does provide the solutions. So on this one, I can just see I have the one solution because it bounces off of it. So I have just the single number 1. So now we can look at graphs. Don't forget, square root method. We did that. And then factoring, we've done that. We also looked at a graph, but that's not listed because we don't use that a lot because it's imprecise. If it crossed somewhere in the middle there, we wouldn't be able to tell where it was. But the quadratic formula always works. This is the quadratic formula. If you don't know it, make sure you write it down somewhere. You're going to need to use it fairly often. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, I know this doesn't make much sense to you right now, but it'll come back up later that what that quadratic is doing is solving for this middle value right here, this one. Because we have something coming up later called quadratic and form, and it will still help us find what the middle thing equals, and that's going to make a difference. Okay, the part underneath the square root, b squared minus 4ac, is called the discriminant because it lets you know how many and what kind of answers you get. Generally, you're going to want to calculate that first, okay? Because if you try to put all of this into your calculator at once, while it will let you put it all in at once, then it can mess up the kind of answers you get. So you're going to want to do that discriminant part first, just the part underneath the square root. So when we apply this one, we're going to say x equals, and you'll hear me say the opposite of b instead of negative b, because if b is negative, like it is here, then the negative in front of that negative actually just makes it positive again. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, and a was this number right here in lead. Now, we want to calculate this part first, okay, and find out what that is before you do anything else. So you can use your calculator and enter that. As long as you use the parentheses, you can enter it from left to right, just like I have it here. But this is 36 minus 12, and 36 minus 12 is 24. So now I have 6 plus or minus the square root of 24 all over 2. Now you need to simplify the square root of 24, so I have 6 plus or minus, and I believe we've gone through that at a point before. If you need some help with learning how to simplify those things, though, I can help you. What divides into this that has the square root? Well, since 24 is 4 times 6, and 4 has a square root of 2, then I can say that is 2 root 6, and it's all over 2. Since they're both over 2, I can divide 2 into each one of those, and I get 3 plus or minus the square root of 6. Now your calculator would not, if you put all of that quadratic into your calculator once, what's going to happen is it is going to give the square root of 6 as a decimal, and it's going to be an irrational decimal that doesn't stop, and that's not what you need. Now when you enter this online, chances are you've got to enter it in 2 separate features. So you're going to enter 3 minus the square root of 6, comma, 3 plus the square root of 6. I'm not going to write it down separately each time that we do this, though. It just is extra writing. I'm sorry that you have to type it in that way, but there's no plus or minus key. This one then will again use the quadratic formula. Now why, besides me just telling you? Well, if we get it lined up in the correct order, 5x squared plus 3x minus 1 equals 0. So now it equals 0. If I were going to try to factor this, what would happen is I would need 5 times 1 is 5. What multiplies to 5 and subtracts to 3? There is nothing, so it doesn't factor. So factoring is just not an option for us. So when factoring is not an option, then we're going to go to our quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now I know I didn't put b in parentheses here, and I did on the previous slide, but that's because on the previous slide it was negative. And when you have a negative number, you're going to need to get that in parentheses in order for the squaring to make it positive like it should. Okay, so first thing we want to do again is we want to calculate this discriminant right here. So if you do that, we get 9 plus, because the two negatives undo each other, 20. So that's going to be the square root of 29 right there. I have negative 3 plus or minus square root of 29 all over 10. Now, this is correct. Okay, nothing wrong with this. There's 2 answers here, the positive and the negative. I cannot reduce this one, though, because you can't put just the 3 over the 10. Now, you can write it separately and say negative 3/10. And I'm still going to write plus or minus. I'm just pointing out that you can separate that rational and irrational part. Okay, so you have 2 answers here, one with the plus and one with the minus. And you can write it both ways like that. All right, so now we've looked at the quadratic formula. We'll do another one, because this one, my focus here is just make sure you rearrange these correctly, because you have to have them this ax squared plus bx plus c equals 0 line up first. So I need to bring that over and let it land right here in the middle. So I have 4x squared minus x plus 3 equals 0. And now quadratic equation or quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Simplify the discriminant part first. This becomes 1 minus, and 4 times 4 is 16, and 16 times 3 is 48. And so then I have x equals 1 plus or minus the square root of negative 47 all over 8. And of course, since there's a negative under the square root, we'll take the I out. And again, I'm going to go ahead and just write this separate. This is two different fractions this time, 1/8 plus or minus the square root of 47 over 8. And then behind that entire thing, I can put my I. And again, you've got to make sure it is not underneath that square root. It was fine to put it in front. You just got to make sure it's not underneath the square root. So this is what I was mentioning earlier when I said it's going to solve for the middle one. Sometimes we don't have an exact quadratic, but we have something that is quadratic in form. It looks quadratic. It's got the 3 terms. The last term is just a constant, but it's not our squared and x. What happens is that the very first exponent is twice as big as the middle one. Twice as big as the middle one. So if I use the quadratic equation on this one, it's not going to solve for x, it's going to solve for x squared. But this one is quadratic in form. Another example, it wouldn't matter what that very first thing is. If I put 4x to the 10th plus 2x to the 5th minus 1 equals 0. This one's also quadratic in form, because if this is 5, 10 is 2 times 5, in the same way up here where this one is a 2, this one is 2 times that 2. Okay, so if it's twice as big, it's quadratic in form. So if I were going to apply the quadratic formula to this last one that I just wrote, what it would solve for is not x, but x to the 5th. So let's apply that here. Let's solve this one. When we solve this, it is going to solve for x squared. So I'm going to use the quadratic, but instead of saying x equals, I'm going to say x squared equals. And that means when I get totally done, I'm going to have to take a square root to find out what x is, because x is going to equal the square root of my answer. But here, x squared equals, and now I apply the quadratic, the opposite of b, plus or minus the square root. Oh, what happened there? By the way, if you're old enough to know what it sounds like to sing Pop Goes the Weasel, you can actually learn the quadratic to that. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so that's b squared minus 4ac all over 2a. So this is x squared equals 3 plus or minus the square root of, and it's going to be over 2 because don't forget, I need to go back in there and calculate the discriminant first before I try to do the rest of the math. So that's going to be 9 minus 8. So that's going to be the square root of 1. Hey, that's handy. Now the square root of 1 is 1. That is 3 plus or minus 1 over 2, which gives me 2 answers. 3 plus 1 is 4. 4 over 2 is 2. 3 minus 1 is 2, and 2 over 2 is 1. But this is not finished, because that's what x squared equals. So x is equal to plus or minus the square root of 2 and plus or minus the square root of 1. Of course, the square root of 2 doesn't really simplify, so we have the positive square root of 2, the negative square root of 2, and then the square root of 1 does simplify, so we have positive 1 and negative 1. So what you can see here is that we actually have 4 answers, not just the 2. This was quadratic in form, and then we had to finish it up by taking a square root. First of all, you want to get it lined up, so we have x to the 4th plus 3x squared x squared is equal to the opposite of b plus or minus the square root of b squared minus 4ac. Now, it's important that you realize that c is negative because we had to take it to the other side, otherwise it's going to cause a problem, all over 2a. Now I'm going to look at that discriminant part first and simplify that. So that is 9 plus 40, so that's the square root of 49. Yay, got another one that just happens to work out. So negative 3 plus or minus, now the square root of 49 is 7, and it's over 2. Again, though, that's not what x equals. 3 plus 7 is 4. 4 divided by 2 is 2. Negative 3 minus 7 is negative 10, and negative 10 divided by 2 is negative 5. Now we take the square roots, so I get plus or minus the square root of 2 and plus or minus the square root of negative 5. But of course, because of the negative, I will take an I out. So I again have 4 solutions. I have the square root of 2, the negative square root of 2, the positive I root 5, and negative I root 5. Okay? So again, what we've been doing here is solving something that is quadratic in form. When you're dealing with quadratics, we have general form. That's pretty much what we've been dealing with, where it's equal to 0. On the other, now vertex form is very handy because you can look at it and tell where that turn point is. So whenever you have the turn point, no matter which direction it's going, that turn point is the vertex, and the vertex is called HK, all right? So we can look at this and tell what the vertex is. When we are trying to find the vertex, the easiest way I can tell you to do it, this doesn't look easy, but it really isn't bad, is to deal with the opposite of b over 2a, which should sound a little bit familiar to you now because that's part of the quadratic formula, but it doesn't have that square root stuff in it. But it's the opposite of b over 2a. And then what happens is after you know that value, you plug it in. Plug it into what? To whatever your equation is. If you were to look at the Pearson videos or They Help Me, they're going to tell you that you need to go through completing the square, but that's a lot longer than this process. So what we're going to do is we're going to do the opposite of b over 2a, and we find out here that that equals negative 3. Then we are going to find f of negative 3 by just plugging it in, and of course you can use a calculator to help you. But negative 3 squared plus 6 times negative 3 plus 13, and we're going to simplify that, so that is 9 minus 18, which is negative 9, plus 13, and we get 4. So the vertex is negative 3, 4. Now, once we know the vertex, we're ready to write this in vertex form, because vertex form was y equals, or f of x equals, a parentheses x minus h squared plus k, and this vertex I just found is hk. Now, what is a, you might ask? Well, a is the same thing that it was before. It is that number right in front of x squared. So here I can write vertex form would be f of x equals 1. I don't have to write the 1 down, so I'm just going to kind of make it dotted again. It can be understood. I think when you're doing it on homework, they don't want you to type it in. x minus negative 3 becomes x plus 3 squared, and then plus k will be plus 4, and that's vertex form. And because you can do all of that plug it in part in your calculator, it's really not that much writing. So you will need to be able to change something from standard form into vertex form. We also have a few word problems on here, so let's just kind of look at what all this is. This is a picture that goes along with, if you have a rectangle that's 10 by 20, and you cut out a corner from each piece of it, and then you're going to fold up the edges to make this box. The area of the resulting base is 96 centimeters squared. So right here, the area is 96 centimeters squared. What's the length of the sides of the square? Well, the length of the sides of the square, since that's what we're trying to find, that's going to be x. So I'm going to go back over here and put an x. But since they're square, every one of those is an x. They're all the same length. Now what happens is that if you look between this little cut and this little cut, the distance is no longer 20. This distance is 20 minus the 2 x's I took off each side. Similarly, if we look in between our cuts the other direction, this distance is not 10, it is 10 minus 2x. So as we fold it up, the short side here is 10 minus 2x, and the long side then is 20 minus 2x. We know that length times width is my area. And that means that I have 20 minus 2x times 10 minus 2x, that's my length times my width, to equal my 96. Now I need to solve this for x, but unfortunately I can't do it yet. I have to get this simplified, then get it equal to 0, and then solve. So there's actually several steps involved here. So first of all, if I simply FOIL it together, first, outside, inside, last, okay, now I'm going to line it up. Here's my squared term. I'm going to write it down first. Then the terms with the x, that's going to be 40x, negative 40x minus 20x, that's negative 60x. But I need to subtract 96 from both sides of this so that it will equal 0. So 200 minus 96 is going to be 104. So that's plus 104 is equal to 0. This is the quadratic that I need to solve. Now, I happen to notice, it's okay if you don't, but I happen to notice that all of those numbers are divisible by 4. So if I divide everything by 4, I have x squared minus 15x plus 26 is equal to 0. Now I can solve this for x because this is a quadratic. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Just like before, I want to simplify this discriminant first. Negative 15 squared is 225. 4 times 26 is 104, so that's going to be minus 104. 225 minus 104 will be 121. So now I'm going to have 15 plus or minus the square root of 121 all over 2. The square root of 121 is 11. 15 plus or minus 11 over 2. 15 plus 11 is 26, and 26 divided by 2 is 13. 15 minus 11 is 4. 4 divided by 2 is 2. So it seems like I have 2 possibilities, but one of those is not going to work. And it's this top one, because 13 does not check. If I plugged a 13 in right here for x, then I would end up with a negative side length, and that's not possible. So in this case, the only one that's possible for me to use is 2. So the side of the square is 2 centimeters. Now, I did solve that by the quadratic, but that doesn't mean it would not have factored. So if you get comfortable factoring, one thing you might notice, and I'm just going to kind of go up here to the upper right and do that, is if I had written x squared minus 15x plus 26 equals 0, I might have asked myself, well, what multiplies to 26 but adds to negative 15? And I would say, oh, well, that is, I can take a negative 13 and x minus 2. That is the factoring. And then when I solve each one of those, the solution to this one is 13, and the solution to this one is 2. Factoring is shorter if you recognize you can do it and learn how to do it. Still yet, though, this 13 does not check, so the only answer is 2. And of course, that was in centimeters. I believe that that's finishing up our lesson. So if you don't need any help with factoring, you can go ahead and quit watching this. The rest of this is some factoring review. Just going through the review of factoring, what is it that I've been doing to figure this out? And you've heard me saying it, but what you want to do is, if your leading coefficient is 1, start at the back and just kind of bounce forward. So you'll hear me say what multiplies to like 15, but adds to give me 8. That is what I'm doing with that last term, and then bouncing backwards to the front. Now it is a positive 8 because of this plus here. Even if you didn't know immediately, it wouldn't take you very long to figure that out, because you can just start to run through all the things that multiply to 15. 1 and 15, no. The next thing goes into it is 3, and bingo. 3 times 5 is 15. 3 plus 5 is 8. If you did not have a number in front of x other than the understood 1, then you don't have to do anything else except for write your factoring: x plus 3 and x plus 5. I'll go through these pretty quickly, because again, it's going to be that bounce back all the time. Bouncing back. What multiplies to 45 and adds to give me negative 14. Now, the only way you're going to get two numbers that add to the negative really is just make both the numbers negative. A negative and a negative is going to give me the negative. So what multiplies to 45? 1 and 45? 2, no. 3 and 15? No. 4 and, no. 5 and 9. So see, you just kind of have to go through until you find them. And 5 times 9 is 45. Negative 5 plus negative 9 is negative 14. So now I have x minus 5 and x minus 9. Next one multiplies to 32 and adds to negative 8. Well, what multiplies to 32? 1 and 32? No. 2 and 16? No. 3 doesn't go. 4 and 8? No. 5 doesn't go. 6 doesn't go. 7 doesn't go. 8. Oh, well, I've already met myself then. 4 and 8 didn't work, but yet I've already worked my way up to 8. This one is not factorable. So that's how you would know that we would need to go use the quadratic formula. This one does not work, but it doesn't take too long to figure that out. What multiplies to 6? Adds to give me 5. It's important that you recognize it adds because of this right here, what multiplies to 6, but adds to 5, because if it had to subtract, we'd have different numbers. But 2 and 3 add to 5, so I have x plus 2, x plus 3. What multiplies to 44, but subtracts to give me negative 7. So 1 and 44, 2 and 22, 3 doesn't go, 4 and 11, oh look, 4 minus 11 is negative 7. Multiplies to 15, but subtracts to equal negative 2. I'm just going to kind of do that up there. 3 times 5, but if I put 3 minus 5, I do get the negative 2. The order makes a difference, though. If you put 5 minus 3, it may multiply to the right thing, but you're not going to get the right difference. Multiplies to 90, but subtracts to negative 1. 9 minus 10. 9 times 10 is 90. 9 minus 10 is negative 1. So I have x plus 9 and x minus 10. So besides the ones that all have that leading coefficient of 1, you know, they just start with a plain x squared. What if they have another number in front? So I know this looks hard. It's really just got a couple of extra steps in it. We're going to start by multiplying that first number in, and then we will finish by dividing that first number out. So when we do this one, if I could draw some lines up above it, I'm going to start off by saying 2 times 30, and that gives me 60. And then I need to know what multiplies to 60 but adds to negative 17. So see, I've still got the adds. I've still got the negative 17. And we're not going to worry about these denominators until that very end. So you just start thinking about what multiplies to 60 but adds to 17. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12. Okay, well, if I put 5 and 12, they add up to positive 17, so I make them both negative, so I get negative 17. Then, after you've done that, you put them over that first number again. We start with it and we end with it. Negative 5 over 2 does not reduce, but negative 12 over 2 reduces to negative 6. Now, if you have a bottom number, it says bottoms up, bottom number goes up front. You want to take this 2 and swing it to the front of your parentheses. So we end up with 2x minus 5. And then our other one, we didn't have a bottom number, or you could say it's a 1, but we just end up with x minus 6. We'll take that leading coefficient, multiply it in at the beginning, and then we take that leading coefficient and divide it out at the end. So let's do a couple of these. Remember, we're going to start with that arc and then bounce. So I end up with 2 times 3 is 6. What multiplies to 6 but subtracts to give me 5? Well, here's 6 minus 1. 6 times 1 is 6, but 6 minus 1 is 5. I started with the leading coefficient of 2. I need to finish with that coefficient. Reduce the part that reduces, so this first one just becomes 3. So I have x plus 3. And now for the bottom one, swing the bottom number up to the front. So you have 2x minus 1. And that's factored. Next one will be 6. Start with the leading coefficient. So 6 times 4 is 24. And that's doing the 6 times 4 is 24, what multiplies to 24 but adds to negative 11. So it has to add to negative 11. 1 and 24, 2 and 12, 3 and 8. Bam, 3 and 8. Because 3 plus 8 is 11. If I want to make them negative, I just make both the 3 and the 8 negative. Put them both over my leading coefficient. Now both of these reduce. So this first one reduces to negative 1 over 2. And the second one, I can divide both of those by 2, and I get negative 4 over 3. Bottoms up. Bottom number swings up to the front. So I have 2x minus 1 and 3x minus 4. And that is factored. Okay, so that's kind of the end of our review with factoring. Don't forget to send me a question if you have any, whether it's email or ask my instructor. I'll be looking to hear from you.